So yes, we have about 15 minutes now. We'll talk about guessing versus knowing. And basically we put this webinar together because we have a lot of prospects and customers asking questions about, what the way we approach API security versus maybe more AI oriented type of approaches. And we really think there's a place for both. And that's what I want to kind of demonstrate today. And also so that you understand the approach we have taken at 42Crunch for API security, which is based on OpenAPI. But before we get and talk about this, I wanted to start with an example, very recent example. I don't know if you've seen that from Starbucks, this from a couple weeks ago. And what happened here, and I really encourage all of you to read the article I have put here in the header, if you haven't done so, to understand the actual methodology that the hacker has been using to get to those accounts. And he explained this really well, and it's actually very illustrative of the way hacking usually happens, because by definition, hackers don't know how the API is working. So what they're trying to do is to discover things that you don't want to expose. And the way they do this is just to poke around and test many invalid paths or invalid verbs or invalid data. And in the case of Starbucks, what happened is what they discovered pretty quickly is there was basically a site behind the API, and they could, probably get to the root of that, to go down the tree and have access to information that they were not supposed to have access to. So what they've been trying to do is what you see here in gray and white, the path they're trying. They tried to trick the web application firewall that was deployed in there by putting a path. I don't know if you see that in light blue, but it says ... So I'm staying where I am. ... right? So they first tried ... So tried to go up all the way to v1 me, basically, right? And that didn't work. So they said, okay, well, let's see if we put a dot there in the middle, which means, let's say where we are, it actually works. And it did, probably because behind the scenes, there is a static rule that searches for repetition of ... but didn't plan for having dot in the middle. So that actually worked. And then from there, they started going all the way up into the arborescence of the API, and then finally found the root and were able to go down all the way to something that is, so you see there's a lot of ... and ... here. So they went all the way up after like 7 levels. They were basically at the root of the API under this proxy thing. And then they were able to go down to search v1 and then a bunch of things. And they tried accounts, and they tried users, and account profiles, etc. So a set of predefined let's say a vocabulary, I would say, of different resources that they could actually get into, right? And out of the probably 100 or 200 that they tried, and a few got a hit, and that's how they got into basically all the accounts within Starbucks. So this is a hack, by the way. It's an ethical hack, so it's not something that there's no breach behind it, right? So none of the accounts, if you have an account at Starbucks, don't be scared. It didn't got breached. Now, how did this work, right? It worked because the hacker who did this was able, through trial and error, to get to the information that he wanted. Not only because he was able to navigate within this tree, but also because the responses that he got gave him some information on whether this was like an existing path or a non-existing path. So the combination of poking around and the responses that came back allowed him to basically do the breach. And it's normally how this is going to work. Hackers when they try to get into something, obviously it's like a black box that they have to discover through trial and error. So if you want to learn about this from the hacker perspective, I think it's very interesting. I put here a link to a really nice video from a lady who's doing a PhD around API security and has created this very interesting sample API and all the methodology around it to teach basically hackers how to hack APIs, but it's also very useful when you're the API providers to understand how hackers are actually approaching this problem, right? So basically, why is this happening, right? Why do we have those problems? And basically, we have those problems because for the past 20 years, we created tools that allow us to do API application security. We keep having two issues. One is we don't know what the application does, right? So in the end, okay, there's a web application when WAFs were first created, there was no way to describe, oh, this is my application and that's how it works. No, it doesn't work this way. So in that case, the only kind of solution, the easiest one out of the box, is to take an approach where we would rather look for things we don't want. So we don't know what requests are going to come our way. So in that approach, we look at all the data coming our way and we put some patterns to say, hey, this is stuff that I know is a signature or something that probably I don't want to let in, the typical injections and scriptings, etc. Think of this as an antivirus, right? And basically you have the signatures of the viruses and you put in a database all the signatures that you know about, and then you compare what you have against that list of signatures, and there is a match, then this is probably a malware, a virus, etc. Okay, so that's one problem. The other problem is we usually do this way too late in the life cycle. So we'll talk about this, but we're trying to do security very late after the whole application is actually written, which makes it much, much, much harder to actually do and difficult. So after all this time, so it's been a long time since web application firewalls existed. What now we're saying is that, okay, well, there is more and more data, there's more and more API, we need more and more power to actually analyze all of that. So let's, rely on something like artificial intelligence to analyze all that information. But again, we're not taking the approach that we know, we're taking the approach that we don't know, and we're going to analyze some patterns of behavior and see if we detect something that we actually don't like, okay? So that's where we are. Now, what we approach it from a different way, right? And the different way is to say, there is a positive security model. So as opposed to just looking at all the data and either look at signatures of things I don't want, right? Like the threats that I know about. I'm just going to flip that around and say, I know what I want, right? I know the traffic that I want. And the traffic that I want is my API traffic in the case of APIs, and I can describe that, and we'll get into that. So when I say positive security model, what I mean is, by default, something which is not declared cannot get in, right? So we only allow access to whatever is described and approved. So we trust that what is inside our description, our definition, what is allowed to get in is what can actually get in, right? But all the rest is actually pushed back by default, right? And we can apply that to requests and we can apply that to responses equally, right? Now, by definition, a positive model, if you talk to anybody in the security realm, they will tell you, of course, it's more powerful to have a positive model than a negative one. And what I mean by negative is this other approach is based on threat signatures. Why is this more, is a preferred approach? Well, because it's easier to control what we give access to, because we declare what we're going to give access to. So that also going to limit the false positive, because we know usually much better what we want in than those threats that can actually come. But the more important part of the positive versus negative is the threats. So if the negative model is based on the fact that I have threats and I need to describe what those threats are, until actually I can detect them. You can quickly imagine that as new threats come in, it's the same if I go back to my antivirus example. If a new virus pops in, then the people who are bringing to you antiviruses like the Nortons and the Symantec of this world, they're constantly monitoring those new malwares and antivirus so they can update their database with those new signatures and push those databases to you. And only when you have updated the database do you now have the capability of recognizing that threat and actually blocking it, okay? So in the positive security model, we don't care so much about the threats, right? Our job is to make sure we keep up with what we want, not what we don't want, right? So even if there are no new rules that we have put in place to detect and block the threats, right? That's okay, because, in a sense, what we want to focus on is, oh, this is what my API does, and that's only what matters to me, right? And this is a traffic I'm going to basically accept through this API. Now, if this is all so powerful, why haven't, are we all doing positive security model, And as a CISO told me about a month ago in a presentation, he said, but this is impossible by default. Keeping up with positive security model is something we always wanted to do, but it's not possible because it's very complicated. Now, the difference in the API world, right, is that we have this capability because we have a standard to actually do that. But otherwise, it's true that having a positive security model and keeping up with that positive list is a constant work, right? And that's why we usually in the traditional web application firewall model, this is not the default way of working. Although traditional web application firewalls can actually use an allow list and say, well, this is what I'm going to allow. The requirements to actually do that in terms of human cost and keeping it up is actually pretty high, right? So that's why usually we took the other approach, which is to deny rather than allow. But in the API world, where we have a luxury, right, which is OpenAPIs, and that's what we wanted to talk to you about today. So if you don't know OpenAPI, you may have heard it about Swagger, as we said, and I think in the webinar abstract, you should really start calling OpenAPI now. From a history point of view, this is a standard that was created by a company called Swagger that got then bought and acquired by Smartbear. And the Swagger brand belongs to Smartbear, and the new specification that they donated to the OpenAPI initiative, it's called OpenAPI. So we have to call that OpenAPI. So Swagger, OpenAPI, that's the same conceptually, but if you're working with version 3 and the latest version, this is really OpenAPI, it's not Swagger. Anyway, long story short, long list here of people who are supporting this. We are one of those companies, but you can see all the major brands and names here, from Google to IBM to Oracle to SAP and Software AG or MuleSoft. But also, as you can see here, they're customers on that list. They're vendors, not only vendors and people doing software, but people where APIs are so important to them, like eBay or Bloomberg, or even Her Majesty government, for that sake, or Open Travel, where people who actually are going to expose open APIs to the world and participate into this initiative, so that they, because for them it is critical, like every single eBay API is described using OpenAPI. And for them, it's very important to keep an eye on and helping progress this specification. Now, what is the role of that? So essentially, the OpenAPI specification is going to help you describe REST API contracts, right? It's language agnostic. So this is very important because right now, it's the only way I know to describe any REST API. I really don't care if you have an API that's exposed in some API management, or if you are generating your OpenAPI from Spring Fox and Spring Boot. type application, or if you're doing this in PHP, all of this really doesn't matter because we have a universal language across all those APIs. And that's really very critical as well, because it allows you to have a common language across everyone on this is what my API actually does. That's the whole goal of that specification, right? So traditionally, this is something people have been using for documenting their APIs, both for internal and external consumption. This is where I'm defining, hey, this is what my API does. This is how you call it. This is the format of the data, and that's what I'm going to answer to you, right? But more and more, at least as what we see with our prospects and customer, this is becoming one pervasive. So it becomes something which was like a nice to have for your APIs and documentation to a must deliver across all the APIs. And second, we see more and more people starting from the documentation, from the definition, sorry, from the OpenAPI specification, and then doing the implementation, right? So they can agree between the consumers and the producers of the API on what the interface is going to be without making any investment in actually doing the implementation, but they can create some mockups and work on the integration this way. And then once everybody is happy, then we'll start doing the implementation in whichever way we want, right? So it's a huge adoption. If you're wondering what the adoption of this is in 3 years, and you can read that report from Smartbear, we went from 25 to 70% of people using this. That's certainly what we see in the people we're working with, and more since version 3 came out about 3 years ago now, right? And as I was mentioning, this is really being mandated by a lot of companies to describe all APIs. The eBays, the Stripes, the GitHubs, the PayPals, the Box of this world are using that. You can, if you have never seen those or you want to see how it works, there's tons of public APIs on this APIs.guru site. So you want some samples. And again, whatever way you choose to actually create your APIs, there is tools for you in the open source community to generate code, to edit, to this pretty much every single language is covered here, whatever you want to do. Okay, so what we're proposing ourselves here is really to use that as the base for configuring and knowing what the API is actually doing. And I'll show you that in the demo in a minute on how we're using this. So now our value proposition is to say, we're going to use this OpenAPI specification that describes what the API actually does to decide, hey, I'm going to accept this call in or not. That's going to be our positive security input, and we'll see that in the demo. Now, from an AI perspective, right, what is it that I could use AI on top of that, on top of what we're doing? Of course, we know. Now, there's no one versus the other here. I think there's a space for everyone. And certainly one of the top, I would say, use cases that we do not cover because it's not linked to the data and validating the data. It's more about navigation patterns, right? So something like my API has been built in a way that I'm supposed to do, let's say you're a bank, right? So I'm supposed to first do a login or authenticate in some way. And then I'll probably go to my banking homepage and I click on the button that calls behind the scene list accounts, right? And then I'll click on an account and I'll see the details and then I'll see the movements on my account of money, right? So that's kind of the norm, I would say. Like 90% of people, when they get into using the API, that's what they do. Now, if somebody's trying to do this in a complete erratic way, so they're making the right calls, they're passing the right data, but they don't do the login somehow. So how did they get in there if they didn't do a login or their notification before? And then they get straight into get account details and start enumerating account IDs. So this is the type of behavioral patterns that should be emerging, saying, whoa, there's somebody here who's really doing something completely out of the norm, right? Whatever the norm means. Remember, this is statistic and this is Gaussian definition, but the norm is not what people you normally do. So we should probably flag that. Somebody can go and investigate, because it might be the sign of somebody who maybe stole a token and is reusing it, or just got a token through the normal ways, but is now reusing it to abuse the API in a way, right? So that's the type of things that, you know, among a massive number of requests that have millions of requests coming to my site, to my API, I can flag this among this massive amount of data, right? So that's one very, very valid use case, right? Another one we've seen is data discovery, such as analyzing the traffic. So there's a huge problem out there. On a lot of customers are telling us, large ones in particular, we don't really know what we have here. We know there are some APIs out there that are not really on the radar, and you know, we want to know and discover them and know that they exist and report them, so that people can go investigate those endpoints that we didn't know we had, right? So again, among the thousands and the thousands and millions of calls, which one are the ones that are not, you know, recognized and flagged as known APIs, right? So we take a different approach to that, which is more a governance one through CI/CD and discovering APIs through, you know, looking at your GitHub, etc. But that's not an option. Then looking at the traffic can actually be a right approach, right? And something we'll probably look at in the coming months. So that's kind of the two main, I would say, AI-based scenarios that we see being really useful, because again, they share this approach of having a massive amount of data where manually it's impossible to go and check and see, you know, what is it that I don't know that I know? Is this, you know, manually following the flow of somebody navigating your API? That's not going to work, right? So having something automatically analyzing that on top of the data is actually extremely useful. Now, what you have to remember, though, about the way AI is working, this is all about statistics, right? What this is going to do is just to define a probability that this behavior that we're seeing now is actually not accurate, right? It's not something we wanted and deserves probably some further attention. So it's in order to create this statistics, you know, to generate this probability, we need data, right? And so you're not going to stop anybody on the first bad request. So if I'm looking at my Starbucks example, and the first time this user is doing this ... we're not going to stop him, because right now we don't know if this is bad or not, right? Now, if he does it 15, I don't know, 100 times, 1,000 times, then you're going to say, oh, that starts popping up in the probabilities, right? So you really need a lot of problems in order to detect and raise an alert. And then there is the training aspect, right? So every API is different. You will have to train them for each API, and with the real data, not with test data. You need the real behavior, which is, you know, what AI's engine have become better and better at doing, is at learning faster and faster. The technology has not much changed on the approach for the past 10 years probably, but the way we're doing it and the speed at which we are training the system is much, much better and has much more progressed in those last years. So we can actually be ready to detect things much faster than we were before. But you still need that training and that set of data to actually make it happen. So that's probably at least what we see from some customers talking to us. That's not going to work for you if you have very low traffic, because you will have never enough probabilities to actually, traffic to define a high probability that this is 95% something that I don't want, okay? So now the other aspect of this is, do you want your system to stop and block, or do you want it just to raise alerts without actually doing something, right? And here we have different feedback from different customers as well. It really depends on the type of transactions that you're actually running, right? Because the key thing is, if engine is blocking something or is not blocking something, can you explain why it was blocked or why it was not blocked, right? And that's the key problem, is to have some explanation AI, something that can tell you, this is the reasoning I have been following, and that's why I have decided to block this, or this is the reasoning I have followed, and that's why I decided not to block this, right? And if you decide to block, let's say you ban their IP, because there's not much more you can do. You can say, okay, we've detected this guy is calling from API foo, let's block that IP, right? So they cannot make more calls, or let's ban whatever. Then, of course, if it's just the IP, they will create another and another and another. So they will just continue a bit later. You're going to slow them down, but you're not going to prevent them from getting in until you detect another IP with the same behavior, and you do that again, okay? So what I'm just trying to get your mind around here is what is right and what you have to do for your particular use case and what you're trying to do from an API security point of view, right? So our approach is quite different. And what we see is from the POCs that we're doing is the main problem people have is they're not covering even the basics. So forget about, you know, the behaviors and moving around. Let's focus first on locking down our API from what we know, which is this OpenAPI definition, right? So we know what this API is supposed to do. We know the data it's supposed to receive. We know the data it's supposed to return. So let's do that and use that first, right? And lock that down first. And that's going to cover a lot of the typical problems, right? And we'll get that to you get to that with that hack Starbucks thing, right? So let's do that first and lock down the API. So how are we doing that? I think you got the drill now. We're using this OpenAPI definition that probably all of you are writing now to a certain level of maturity. And we use that along the life cycle of the API to actually bring you security, right? So we first look at design time. This is my API contract. Go and audit it, right? So what we'll do is we'll analyze this contract and we'll tell you, hey, you forgot security there, or hey, okay, you told me that your API is actually taking some, let's say, string and integer in as parameters of a certain call. But you know, what kind of string? Like, tell me more. You know, what are the limits on this? So put some boundaries around that data. Or other things that you know, like, oh, you told me there is a response in here and it's 200, but there's no schema attached to it. It's like when your API responds 200, it doesn't say anything, like it doesn't give me a response. Is that normal? Right? So we'll just bring your attention on all those potential things so that you create the most, you know, I would say perfect positive model list possible, right? That has all the information about what the API is actually doing, right? And then we'll just invoke also the API using that contract, just to make sure that during the development, and we see that a lot at our customers as well, even for people who are doing an API first design approach, right? So they start with the OpenAPI definition of the API, and then they create the implementation from that. And at some point in time along the way, somebody changes in the implementation. So this happened to me in a POC last week, where we saw that the contract was saying, oh, when this response comes back, this field is a number, right? And then when we did the test with the implementation, we realized that actually the implementation had been changed. So the data that was coming back was not a number, it was a string. And this is something which is in production, but nobody has complained about this. It also proves somehow that they never really validated that the response, and it works also for requests, it's valid for requests as well, was actually conforming to the actual schema that we were actually expecting, okay? And then finally, we do the protection on this. So what I want to show you now, right? I'm gonna start from a blank sheet here, just to show you the power of doing this. I have a cluster in Kubernetes that I pre-created just you know, to save the 5 minutes it takes to create a Kubernetes cluster in the cloud. And we're going to take an open banking API. So an API from the, if there are people from the UK on the phone, this is the CMA open banking. So the definition of the transaction and accounts API that is used for all the banks in the UK for open banking, right? So I just took that and just added a specific, the link to where it actually resides to it, and that's all. And I'm just going to take that as is, and I'm going to deploy our firewall in front of that, nothing else, okay? So I'm gonna go do live, just going to escape here and close this. And we'll start in our platform, okay? So in our platform, this is our SaaS platform. So in the platform, the journey starts with an OpenAPI file, okay? So what I'll do, I'll just go and say import API, and I'll go and import this account info OpenAPI YAML. As you go, right? We'll call it account info, import API. And as we import it, the first thing the tool is going to do is it can run this audit that I was talking about, right? So it's going to give us a score on the definition of the API in terms of security. So there's quite some issues left in here, about 1,000 of them, because this is a massive, actually, API. It's the file is like 75K. So there's a lot of data in there. As you can imagine, this being open banking, we're pretty good on security. But then we have quite a few problems left on schemas definition, which is pretty normal. Like things like what I was mentioning before, like we have some information in there, like this customer user agent, and we just say it's a string, right? And nothing more. So on the contrary of this customer address, for example, where some pattern has been put and the max length as well, for this user agent, there are no constraints. And that's basically what we're complaining about, saying, hey, give us some constraints around this user agent, right? But overall, it's pretty good. So it's good enough that we can take it and use it straight for protection, okay? So what I'm going to do next is simply configure our firewall from this. So I'll just take this webinar. I'll take the account info, okay? And say configure protection. And then the only thing it's going to ask me is to create a token. Think of this is the way our firewall is working. Think of this as a unique ID for the configuration of the firewall. So it knows what the API does. It knows all this information that comes straight from OpenAPI. And it can then actually get its configuration from the SaaS platform and start itself, okay? And that's it, and complete the setup, okay? And what this is going to give me is this UID, right? So I can show it because we're gonna kill it after the show, so doesn't matter if you copy and paste it. So we have this UID, which is basically this ID of that configuration that we're going to use now. So I'm just going to copy that, right? And I'm just going to paste that here. All right, so what this will do, this is a Helm-based install. What this will do, it will spin up basically 1 hour firewall with the configuration that we have given it, and that's it. It's running, so see it's very fast, very small runtime. And if I go back here now, it will tell me I have an active firewall running. So as you can see, I didn't write any rules, I didn't write anything. All I've done is just saying, go protect this API from the OpenAPI file that has been imported, okay? I can show you that file after if somebody's interested. So now what this tells me is I've created something. We have configured this firewall to basically just answer to that name, right? And it will redirect all its requests to and consume the responses from that target URL. So this is like a sandbox deployment from the CMA, from the bank, that's going to respond to us, okay? All right, so now we should have, so this is running, that's all good. Now, what we're going to do is check here. So our firewall is started and exposed to that external IP. So I have to just take that IP in here in my hosts, configure it so that we assign that new IP, right, to this Open Banking 42 Crunch test, which is the name that we have defined for it. Okay. All right, that's it. So if I do a ping of this now, it should ping on this 151, okay, which is what we want. Perfect. All right, so now we have a firewall running, right? We have this pod which is running, which basically sits, as we say it here, right? Which sits between, sorry, as we said in my presentation, which is right there, right? Which sits between the clients, and we're going to use Postman, and this Open Banking API that we're talking to, okay? So if I go to Postman now, all right. So if we look here, you can read this, but what it will do is it will go to Open Banking 42crunch.tests, right? And make this call. This is like the normal data that this API actually expects. If anybody is in the open banking industry and knows about Fappy, those are these specific headers. So Fappy is a specific standard for OAuth for doing financial grade security around APIs on OAuth and OpenID Connect. So there's a bunch of prerequisite headers that you have to send, like a date, your IP address, this is a fake one, a UID, a bearer. We don't have a real bearer here because I'm not registered actually with this API, and some random user agent, okay? So if I'm making this call, right, I will go all the way to the backend. It goes to the bank. This actually answers to me, except that, you know, I'm actually not a registered user for that specific bank API. So that's why it tells me, sorry, I don't know you, go away. But the call went all the way to the bank, came back, came through us, all works fine. And the way I'm going to prove that to you is that now, if I'm making a call which is outside of the contract, all of that is going to be blocked, okay? So starting with, remember our friends from Starbucks, or the hacker from Starbucks, trying to work around discovering path, right? So if I'm trying to put here, you know, .. /.. for example, right? Now, this is us saying, nope, sorry, can't do. We don't know you. So we're going to reject you with this, you know, status 404. We can't find that path. So we can also do the trick of putting a dot instead of a ... Well, I'm going to comma if I want to, but that's still not going to work, right? Now, where I'm going to see that and why it actually fails is in the logs that we upload to the platform, right? So you see we received this ... and well, not a way in Earth, as is not going to work. We can't get in this way. So the other way we can try to get in, so just go back to putting account ID in here, is choosing so the path is right, but the verb is wrong. So something like head or something like put, right? But in here, the contract says, no, you can only use, actually probably didn't put the path properly. Let me just, because this was deleted. All right, so if I have the right path, I didn't have the account ID here. If I have the right path with the account ID and I use a different verb, all of that is going to be also rejected. And that's exactly the way a hacker is actually working, as we said, right? Is by poking around and see if they can call with something that they're not supposed to be able to call. So by using the OpenAPI file to restrict all of this, we just reduce a lot the scope of how actually the hacker can play around. So now they cannot play around putting a different path, right? They cannot play around putting a different verb, even if they know the path. That's not going to work either. So that's the first base. The second base is, okay, let's say I have the verb right, I have the path right. Now, the next step is to play with the data and see what the API is actually doing. If I'm starting to sending it, what actually it does not expect, right? And for each of those headers here, there is a specific format that has been put inside the OpenAPI definition. For example, this date here, so it's supposed to be a date of that format, and it only supports here GMT, and I can't remember what the other one, I think it's CET, we'll see. If I put CET in here, is this going to be working? No, so that's not right. All right, so put back GMT. Right, so if I put back GMT, it works. So see, the format is actually pretty, all I change is the timing, and I can't do that because we're validating behind the scenes that the format which is here is exactly what is written inside the OpenAPI file, and they have restricted it to GMT and something else. I'm gonna have a look, but not CET or Zulu or anything like this, right? So that's for a date. The same will happen for this, which is supposed to be an IP address. So if I'm putting a letter in there, that is not going to work either, right? And if I go back to my list here, right, of what has been blocked, I will see that all of these have been blocking because they don't match the actual pattern that we were expecting. Now, so this is all the basic validation that every single one of us writing APIs should be doing in their code, right? But what we're seeing from every single POC that I do, every customer, is it is not really happening, right? So, and the reason it's not really happening is this is frankly, and if you're a developer listening to this, you will understand, this is frankly boring code in the sense that it's code you have to do for doing all this validation. What I really want to do is you want to run the functionality code, and you want to run the functionality of your API, not so much all this validation. Plus, it's very, very, very easy to forget to, this API, for example, which has a massive number of data. So if I'm looking at the definition of this, right, in Visual Studio Code, you'll see it's a massive API. It's huge, right? There's tons of stuff in there, and more and more and more, right? So it's very easy to forget to put some validation for that stuff, right? So if I'm looking at, I'm just stopping there, they don't know where I am in the API, but if I'm looking at that schema here, right? So it has a bunch of stuff. It says that you cannot have any additional properties. It has some restrictions on the length. It has some patterns which have been put in here because it's 4 letters to identify a code. So this, for example, this is good job. So now if I have this schema and I'm validating somewhere in the code against a schema, that's going to, do what it has to do. But it's very easy to just forget. And if you look in here, actually inside this API, in some places it's very well defined, and some others it's less well defined. So it really depends. Maybe we wrote it and how it was written, or we forgot before we did it. I don't know. But this is all the stuff that the audit is going to tell you about, so you don't forget, right? It's going to tell you, hey, you forgot those patterns. You forgot about this stuff. You have to go and put it, like this customer agent that I mentioned before, or here that schema, or here the same thing. We have a schema here for interaction ID, which is supposed to be a UID. So we know what a UID is, but that is not written in there, right? So that's why the audit is complementary to the runtime. With the audit, we're going to tell you what's missing, but the runtime, we're going to automatically enforce those different rules. Okay, and for that, you don't have to write anything in your code. That's the key thing. So this is an approach where, we really restrict completely the scope of what can get in first, right? And then we'll see about the behavioral stuff. But doing just the behavioral things without doing this is kind of counterproductive, in my opinion, because you're going to let a lot of stuff in that you're going to discover after the fact, right? And you don't stop at the first time, as we're doing here. We didn't have to train this thing, right? It knows by that, for example, this is a bear with a token. If I'm putting something else, I'm putting JWT, which could be perfectly valid, right? In here, it's not going to take it, right? Because that is not what it expects. It doesn't expect a JWT, it expects a bearer thing. So there's no training. There's like certainty of what it is going to do. There is the explanation of why something has been blocked, because it is not in that schema in that place. So I would highly encourage you to start with this. Start by protecting your API using a positive security model. And that's what I have on this slide here. So let me just go back to the slides in there, right? So start by doing the positive security approach so that you discard anything you don't want first, right? So you shouldn't let something in that has not the data you actually require, or the verb or the path, and then you block also all those games that hackers are playing of trying and failing and see what they can discover from that. So you're basically preventing them from playing that game because there's nothing to discover here. We're going to block them systematically, right? And the great advantage, if you're not using OpenAPI today, I would really encourage you to actually do that. It is the open standard for REST APIs. It's easy to use. There's tons of tools. It's covered by every language, so it's extremely easy to adopt and use. And besides the security aspect that we give you, there's tons of other benefits in actually adopting OpenAPI. And finally, one of the key things as well is what I have done here for you in this demo, using command line, so it's easier for you to actually see what I was doing. You can do all of that automatically. You could create something in your DevSecOps environment that takes an OpenAPI, does this audit, and poses, all my APIs must have that type of score, and I don't want to have any problems of that type left, etc., etc. So whatever you want to set the bar in terms of the quality before that API is actually accepted in the pipeline and actually be built and go to the next stage. And we're going to do that very early, right? Remember, going back to what I was mentioning at the beginning, one of the core issues we have in security is we start too late. So adopting an approach like this one based on OpenAPI really allows you to start way earlier, right? And the earlier you start, the earlier you discover those problems, the easier they are to fix, right? And once you've done all of that, if you want to add on top a solution that actually does this intelligence and combines the data and finds those paths, etc., by all means, we're actually seeing them more complementary to what we're doing than the competition. But don't do just that without covering the basics first. That will be like my core message. And from there, we'll be happy to take any questions you may have.
All right, great. Thanks, Isabel. We have a few questions coming up. So the first one, just wondering how it differs from Nginx with WAF being applied. Is it ML built in or something else?
Okay, so no, it's not. So in Nginx, there is a module which is called mod security. And this is used in many other platforms as well, not only Nginx, which is an open source web application firewall. And this works by signature. So this is the approach I was talking at the beginning, where we don't really know what we're expecting. So what we do is we configure the system with signatures to identify things that we don't want, right? So it's kind of the reversed approach of what we are doing. And there is no ML and there's no AI in what we're doing. The entire intelligence here is in the interpretation of this OpenAPI file that describes what the API is actually doing. So what we have done, what our IP is, if you want, is an engine which is capable of consuming natively the OpenAPI definition and enforce automatically whatever this contract is actually saying, as I showed in the demo.
All right, thanks for answering that. Next question. So with Audit, can we ensure that the schema has validation rules, and with runtime, can we throw away validators? Wondering if there's a way to somehow enforce owner validation. Example, only owner can delete its own article.
Okay, so let's step back maybe a bit. So the audit I talked about is not a runtime tool, it's a design tool, right? So when, let me just go back here, maybe it would be easier to explain if I show it. Just get back up there. So when I click on this button here and I say audit this, right? What behind the scene this is doing is it goes and analyzes this OpenAPI file that describes this open banking API. And it goes and analyzes statically all the definitions I have put in there, you know, like the parameters and all the schemas, et cetera, and makes recommendations on what is missing in terms of information. And as you're saying, one of the key things in here is how complete are my JSON schemas? Do they have validation patterns and rules in there, like constraints around what is the format of that data, what is the size of that format? So if I'm looking at, you know, why did we stop this auth date, right? Then I will know which one was actually accepted. UTC, that was the one, right? So when we are sending this request and basically it was failing because I've put CET in there, that's because there is this pattern in here that's in here, and it didn't match that pattern because that pattern says this is the pattern, right? And this can only be UTC or GMT, right? And that's it. So those are my constraints, and there are no constraints on the size here because on the length, because it's already predefined basically in the pattern itself. Same thing here, right? If I have a pattern, a mean length, a max length. So what this tool is going to do is statically help you make this file as rich as possible, and then we'll automatically take that and generate the runtime enforcement from it. So what I've done when I've deployed the firewall is I told the firewall, hey, those are my rules, you know, all of these things natively. And what the firewall does is it reads this. So when it receives a field called xFappy interaction ID, it will first have a look that, oh, is it in the header? Yes. Is that the name of it? Yes. Is it required or not? So if it's not there, then it will raise an error, right? If it were true. And then what is the format for it? Is it a string? Is it max length? Does it match all of those rules? And if it does, then it goes to the next one, right? So all of this is done automatically. Now, doesn't mean you shouldn't do anything in your backend code or anywhere else. No, as a security person, I could never tell you that. The more you validate, the better. But what we have seen from people we're working with is it's not really easy to enforce that this validation is actually systematically happening in the code, because there's nothing that validates that today. There is no tool that you can point to any code and say, tell me if I'm not validating data, because we had this, you know, a lot of problems that would be going away, but we don't have this. So the only way to actually enforce it's done is to kind of extract all this validation and make sure it's done from a governance point of view in that extra layer that we put in front of the API, right? So once we have deployed our firewall in front of an API, then you know that there is validation happening there, right? It's not like you hope or you think maybe it's done somewhere else. No, you know, that's the key thing. And that's really the value position and what we want to do in this solution. I hope this is answering the question.
All right, next question. Do you see any performance issues related with runtime incoming request checks?
It could be if our runtime was bad. So, which is not the case. Absolutely. So if you're going to put a solution like this in place, latency is an absolutely critical factor, because not only do we validate the request, we also validate the responses, right? Because they're, you know, one of the top 10 of OWASP-on APIs is leakage of data or exceptions, right? And if you want to avoid that, it's number 3 on the list. If you want to avoid that, you want to make sure that the data you return is really the data you want to return. So the same way we validate the request, we also validate the responses. And we do this usually, so actually, let me go back to here. Interesting question, and I can answer to it. If we look at the transaction logs here, and you look at the time it takes to actually do things, right? So the validations that it takes, so this is just a simple system on my machine. So as you can see, the validation, so this is the validation of the request, right? It takes 370 microseconds to actually do that. And if there is a response, and we're going to see that because we don't have any response validation, but they're all around kind of, 594, 472. So in other words, it's fast, right? Yes, it will add something like between 1 and 5-6 milliseconds, let's say maximum, to the entire traffic to your transactions. That's kind of what the penalty is.
All right, we'll take one more question because we're coming to the top of the hour. If you're using third-party OpenAPI, for example, ServiceNow, how would you recommend auditing the API to better understand the security controls to integrate for your environment?
Same way you would for your own. So you would, I'm sure ServiceNow has a Swagger or an OpenAPI somewhere. Take that, go and, put it through our audits. You can do that as it says here. You can go to our community site and you have that audit tool, which is open to everyone. You can put ServiceNow in there and see what comes out of it, and then go and tell them to do the same thing. So that's open to all. You can absolutely do that.
Great. Well, we're at the top of the hour. We don't want to take any more of your guys' time. There are a few more questions that were asked, and we'll get to those in our blog, which you will get a link to in follow-up. Is there anything else you'd like to add, Isabel?
No, that's thank you just for attending as ever. If you're somebody who's used to attend our webinars, and welcome, and I hope you enjoyed it if you're a newcomer, and we hope to see you soon on more webinars.
All right, thank you so much, everybody.
Take care. Bye-bye.